In physics, every measured quantity is either a scalar, S-C-A-L-R, or a vector, V-E-C-T-O-R. Things are scalars or vectors, and there are different rules for both of them. Now, this year, we're going to keep our vector math fairly basic, but if you have any friends that are in Physics 12, if you want to have some fun with them, you can say, how do you add two vectors together? And they'll scream out, tip the tail, because I've instilled the fear of God into them on that one. I've walked around with my Nerf dart gun threatening to shoot them if they don't know that, just to try and be over the top and help them remember. What's the difference? Scalars have magnitude only. Magnitude is the fancy science word for size. As an example of a scalar that has magnitude only, mass. An object has a mass of 12 kilograms. It makes no sense to say an object has a mass of 12 kilograms north. Vectors have a directional component, which we're going to write down in a second. Scalars, volume is a scalar. That's 3 liters. 3 liters south of west makes no sense. Vectors have both magnitude and direction. Vectors have magnitude and direction. Scalars have magnitude but no direction, much like your future. Oh, sorry. That's a joke. My future has... Okay, you got it. Some examples you'll learn later this year. Force is a vector. It very much matters what direction you push on an object. It'll move it in a different direction depending on which way you push it. You will need to memorize whether it's a scalar or a vector. I don't think you'll need to bring out flashcards or anything like that. Stephen, the memorization will happen organically because you have an idiot teacher who's just going to keep repeating it over and over and over and over. Anytime I introduce a new concept to you for the rest of this year and in Physics 12, first thing I'll show you is its abbrev. What symbol are we going to use for it? Because we're not writing out the whole word. That ain't happening. Second thing you're going to learn is its units. What do we measure it in? Third thing you're going to learn is whether it's a scalar or a vector. Those 3 things you do want to memorize, but again, you will just out of laziness and repetition. You don't need to bring flashcards or anything like that. Some examples. Scalar, speed is a scalar, 20 meters per second. There is a vector version of speed. Velocity is a vector. That would be 20 meters per second at 30 degrees south of west. That's telling you, Allie, the magnitude, 20, the direction, 30 degrees south of west. What would that look like? You would go west. Which way is west for you guys? West is that way. And then you would go 30 degrees south of west. We do this in Physics 12. This year, our vectors are going to be fairly straightforward. Brett, what we're going to do is we'll say we're going to let one way be positive and we'll let one way be, yeah, we'll just keep it fairly straightforward. Okay. Usually up will be positive and down will be, usually right will be positive and left will be, usually forward will be positive and backwards will be. Not always. Sometimes we'll make something positive because it makes the math easier. We may find, oh, it's way easier to let down be positive for this question because it just makes the math so much nicer. You will need to know that speed is a scalar. You will need to know that velocity is a vector. Ben, if I was a good teacher, I'd have a dumb way for you to be able to remember that speed is a scalar and that velocity is a vector. I can't think of anything. I'm a terrible teacher. You'll have to come up with your own dumb way to remember that. Hopefully you got the hint there. Scalar, time is a scalar. Time cannot be negative. Well, I watched a movie once where they went back. No, time cannot be negative. Time travel into the future, you'll learn later this year, totally doable. Time travel into the past. Acceleration is a vector. I'm going to abbreviate acceleration with Excel. Depending on which way you're accelerating, one way might cause you to speed up, one way might cause you to slow down. The two tricky ones that you will have to remember that I don't have a stupid way to help you keep them straight, unfortunately. Distance is a scalar. Displacement is a vector, and we're going to be talking about both of those today. I don't have a dumb, clever way for this one, Anna, because they both start out with DIS. That really eliminates a lot of what I can do. Oh, vector has a T in it. So does displacement. Yeah, so does distance. Yeah! I've tried all sorts. If you come up with a good way, let me know, and I will give you credit for the rest of my teaching career. I've just memorized it through brute force repetition. I know distance is a scalar. I know displacement is a vector, but I don't have a good way to make it. You gonna make it? I was a long blink. A little tired? Okay. Vectors are in textbooks written in bold font, but it's really, 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 really hard. Don't write this down. To bold font when you're handwriting. Maybe I was just scribbling. So when we're handwriting, we put an arrow above the vector. So to show that force is a vector, we would do that. Although we get lazy and we only put half the arrow. That's just kind of happened over the years. That's a vector. So let me give you a specific one. That's velocity, lowercase v for velocity. That's speed, velocity with no direction. We're going to use a lot of abbreves. Medina, it makes sense. And once you get the hang of it, you'll like it because it's less writing. It's a win, but we are going to abbrev a lot. So if something has a vector on it, we'll put an arrow on it. Mr. Dueck, how fussy are you going to be on the notation? I'm not going to take marks off. What will happen if you're not paying attention, you'll lose the marks naturally on your own because maybe you solved something using a scalar method when you should have used a vector method. But this is a lot thrown at you. Let's talk about distance versus displacement. Distance, it's how far an object has traveled. Hudson, we are not going to write out the word distance. We're going to abbrev. We're going to use a symbol. What symbol? Isaac Newton, who's kind of the father of physics. He wrote the first big book on it. He used a lowercase s, and in Britain they still use that. My problem is that looks an awful lot like a 5, and also the s is from a Latin word for distance. Do you speak Latin? Sure, no. So we're not going to use that one. A lot of textbooks will use a lowercase x, like on a graph, like on the x-axis, and then for a vertical distance, which letter do you think they'll use? Because I asked you to. For a vertical distance, which letter do you think they'll use? Why? Because I asked you to. For a vertical, oh, you just got the joke. Some of them haven't even got the joke yet. They're still, why? Huh? Okay. Yeah, that's not bad, but you know what? I'm just going to use D for distance. I will try whenever possible to pick the letter that starts. We're going to run out of letters eventually, but whenever possible, I'll try and use the letter that starts the word. The units, the SI units for distance, meters. And I abbreviate that too. Yes. Scalar or vector, distance is a scalar. It's how many steps, if the object is stepping, it's how many steps the object takes. Displacement is an object's change in position. Symbol, it should be, well, Isaac Newton used x with a vector bar. We're not going to use that. A lot of textbooks will use s with a vector bar. A lot of textbooks will use x with a vector bar, and that's fine. I'm not going to use that. I'm going to use d for displacement with a vector bar. It's also measured in meters. Is it a scalar or is it a vector? It is a vector. And it's easier for me, sorry for those of you on YouTube, but it's easier for me to just do a visual demonstration with you. So everybody look up. Pretend I'm standing at 0 on a number line, and each step is 1 meter long. So look up, call YouTube, look up. Count with me out loud, all of you. Ready? Count with me. 4. How many steps did I take? What's my distance? Same answer. 4. What's my displacement if I go 3 forward and 1 backwards? My displacement is 2. So ready? Watch it again. Count with me. 1, 2, 3 forward, 1 backward. 4 steps. My distance that I've traveled is? 4. My displacement is 2. My change in position. Let's do another one. Back to 0, 0. Count with me. 3, 4. What's my distance? Same answer. What's my displacement? I ended up there. -2. Or you could say 2 left. What's less writing? L-E-F-T or a minus sign? I'm probably going to use that. Okay? Count with me. What's my distance? What's my displacement? Nothing. 0. No change in position. Okay? Displacement is your change in position. Distance is how far you've moved. Who cares about the direction? Count every single movement. Sorry? Cars measure distance, not displacement. Yeah. Well, in fact, we would have to be careful if you're talking about any race where they start and end at the same place. We would say they've traveled a distance, but their displacement would be 0 because they ended up back where they started from. So displacement only cares about where an object starts and where it finishes. Change in position. It does not care about the path in between. When an object starts moving, it's useful to be able to describe an object's location. Often we'll imagine, Stephen, a number line or a meter stick just laying on the ground or on the paper. We'll use our imagination. Initially, I'll put one in here. So objects to the right of 0, we'll call that positive. Objects to the left of 0, we'll call that negative. Example 1 says this. A bug walks along the number line. It starts at A, walks to B, then turns around and walks to C. Let's draw that in. We'll draw it in with what's called an arrow diagram. So draw an arrow pointing from A to B, and then above it going all the way back. That's its path. Yeah. Okay. Charlie, what distance did the bug walk? You got this. Let's see. 4 forward, 10 backward. Is he correct? Yeah. 14 units, please. Yeah, it says in meters. Ooh, Owen, what's the bug's displacement or change in position? I'll give you a hint. Not 14. There you go. So I'm going to go D equals 14, no vector sign. D vector sign equals -6 meters. Or you could say 6 meters left. I won't mark that wrong. Which one's less writing, Owen? What I would mark wrong is if you said -6 left. I would argue negative left is technically what? Right, not left, right. So don't use double, you know what? Don't not use double negatives because it's confusing. I think I got that right. I have to double check, but I think I said that right. Okay, stick with negatives and positives, easy peasy. Turn the page. Suppose you run along 3 different paths from location A to location B. It says, along which paths would your distance be different from your displacement? I'm going to reverse the question. Of those 3 paths, only one has the same distance and displacement magnitude. Which one? Yeah, so this is the one where your displacement and your distance would be the same. It wants which ones would be different, so that would be different and that would be different. So we can use arrows to represent a displacement. A bike moving along a number line from +4 to -3 meters. Our abbrev for the start position is the word initial, often. And our abbrev for the ending location is the word final, except Katie, what letter does the word initial start with? What letter does the word final start with? We're going to often use a subscripted I for initial and a subscripted F for final or later. And you'll be able to figure out which one is which, Stephen, by just kind of following the time flow of the sentence of the question. And that it's not as complicated as it looks out. So this would be an initial position. We would call this DI, DF, or XI, XF, or something like that. So we'll often use a variable, x or d, to symbolize an object if we're talking about a distance or a displacement, and subscripts, initial or final, to show initial and final. So example 4 says, draw an arrow that shows an object that moves from the -4 position to the -5 position. So here's the -4 position. Here's the 5 position. Look like that. If you wanted me to label it, I would probably say, heck, I'll use the letter X because we're on a graph. X initial, X final. When I draw that little I for initial, because we have people in the back row corner, I'll always put a little curly on the I so you can tell it's not a 1, even if you can't see the dot. You'll see a little curly thing. I'll make it like an italicized I, just a habit. Okay, we got this, we got this. Allie, what's the object's distance? How far has it moved distance-wise? Has it moved 14? Where do we start? That's okay. I think you're looking at the wrong one. Previous. Sorry? Yeah? 9? Yeah? Yeah? 9. Yeah. Keep going, Allie. What's the object's displacement? What's its change in position? First of all, what's the magnitude of its change in position? Same answer. Direction. What direction did it move? So you could write 9 meters right, or you could say positive 9 meters, although when we write numbers, if there's nothing in front, do we know it's positive? So honestly, this is kind of redundant. You could put it in if it just made you feel better to say, I saw the direction, it's to the right, it's positive, and I'm not going to mark that wrong, but I also won't mark it wrong if you wrote 9 meters and said Dueck. I think you'll clue in it's positive. I'm positive. I'm positive that you'll clue in that it's positive. Whatever. The jokes aren't going to get better, Hudson. Just lower your expectations, right? I think I always say, much like a Star Wars sequel, lower your expectations. Don't expect much at all. Draw an arrow showing an object that moves from the 7 position to the -2 position. Okay, here's the 7. Here's the -2. You can freehand the arrow. If you want to use a ruler, you can, but you can freehand it. I'll call this X initial, starting position on the X-axis. I'll call this X final, ending position on the X-axis. Tucker, what's this object's distance? Distance. No, so distance has no direction, much like your future. What? Just 9, doesn't care. What's this object's displacement, Tucker? Yeah. Or you could write 9 meters to the left, but why? Okay. Draw an arrow showing an object that moves from the 7-meter position to the -2 position and then to the 3 position. Okay, from the 7-meter position to the -2 position. That's going to look like this. And then to the 3 position. I guess this would be initial and this would be final, and there's a midpoint in between. I see it. I'm not going to bother sticking a label on it. Ben, I saved this one for you. What's the object's distance? Let's see. It goes from 7 to -2. That's 9. And it goes from 2 to 3. That's 5 more. And I'm showing how you can calculate it instead of just counting one. I've seen some people counting, and that's fine. But I showed you, if you break it up into chunks, you can do a little addition. I agree with you. The D is going to be 14 meters. What's its displacement? I'll give you a hint. Not 14. Loud and proud. Where'd you start? Where'd you end up? Who cares what happened in between? You started at 7, you ended up at 3, you moved 4 left, or draw an arrow showing an object that moves from the 4-meter position to the -3-meter position and then back to, okay. So from the 4-meter position to the -3-meter position and back to the 4 position. Okay. I guess this is initial and this is final. Joey, I saved this one for you. What's the object's distance? Where did it start? And then where did it end up? That's 7. And then what? From here, we went this way. I don't think it's 7. What is it really? 14. Yes? What's this object's displacement? Your hint is it's kind of a trick question. What's its displacement exactly as a number if it ended up back where it started from? Loud and proud. Yeah. Here, 0 doesn't really have a direction, so whatever. You could technically write -0. I'd give you a stink eye, but I couldn't argue that it was wrong. You just, yeah. And you're going to hear me use the phrase all year long. We're going to be lazy but organized. Smallest amount of writing for the maximum amount of information. Yeah, y'all figured it out. Turn the page. So if you've ever thrown a ball straight up into the air and then caught it, Cole, a ball is thrown straight up into the air. It rises a distance of 11 and falls back down, returning to its origin. What distance did it travel if it went 11 up and came 11 back down? Yeah, but what's its displacement as a number exactly? Yeah, yeah. Is that okay for the difference between distance and displacement? Now, you're not going to get questions with number lines on your test. I'm just doing that to help you understand what we're talking about. We're going to get a little closer to what you're going to see because we're now going to combine distance, displacement, speed, and velocity. So speed versus velocity. Average speed is distance over time. It's technically distance over the change in time, where this delta is an abbrev for change in. In fact, I think I put that in the top left-hand corner of your green formula sheet. I think the very, very first thing that's on your sheet, it should say something like delta equals change in, I think. Yes? There's also another, yes, the mathematical version of change in anything is it's always going to be the final value minus the initial value. And you'll probably end up memorizing that one out of laziness as the year progresses because we'll refer to it fairly often. So as an equation, our symbol for speed, we take the velocity symbol and we lose the vector. V for velocity, no arrow, that's speed. Why don't we use S for speed? Taken by something else already. Christine, are you going to make it? Because every time I'm looking over there, I'm seeing this. Okay? Distance over time. Mr. Dueck, how come you didn't put the delta in front of the... Okay. This is physics sloppiness, Nolan. Time, by definition, is always a change in because anytime you're starting and stopping your stopwatch, the software, Hudson, is going the final time minus the initial time to give you how much time elapsed. Because it's always a change in physics, we've gotten lazy and we've stopped putting a delta in front of the t. I think you'll see fairly often on your formula sheet, I typed the delta in front of the t, but we get kind of sloppy that way. What are the units? We can figure this out. Not a problem. Medina, what are the units for distance? What do we measure distance in? Start the letter M. Over. What do we measure time in? Starts the letter S. The units for speed are meters per second. It is worth memorizing what units go with what. I hate memorizing. I hate memorizing. So if I tell you something is worth memorizing, you know what that means? It means it's really worth memorizing. Wake you up. Really worth memorizing. Sorry for those of you on YouTube with headphones. I get great comments when I do that yell. It's a scalar because speed is a scalar. What about average velocity? Average velocity is the displacement over the change in time. Again, where delta still means change in. As an equation, we would write this. Velocity equals displacement over time. If you go on a long trip and you come back home, if you arrive back where you started from, what's your displacement exactly as a number? 0. What's your average velocity technically? That's 0. Technically, your average velocity has been 0 because you have no displacement. So when we're talking about velocity, usually the public means speed. They'll use the word velocity, but what they mean is speed. What would the units be? Okay, Charlie, what are the units for displacement? Starts with letter M. Time. Yeah, if you see meters per second next to a number, it's the speed. If you see meters per second next to a number and there's also some directional aspect to it, it's a velocity. So example 6 says, if the bug's trip mentioned in example 1 took 30 seconds, I'll scroll back. You can stay here. It says, what's the bug's average speed? Average speed is going to be distance over time, and average velocity is going to be displacement over time. Okay. In both of these situations, Laney, what's the time? What does example 6 say the time is? Yeah. How do you know that's 30 is time? Okay, so this is going to be stupid obvious, I hope. In physics, we're going to do a lot of word problems, and a lot of you have a fear of word problems, and the reason is because the ones in math suck. They're contrived. What am I going to let be X? In physics, trust me, figuring out what they're asking for is going to be pretty easy, and figuring out the information, Laney, I just look for units. I actually looked for the word seconds, and then I said, oh, the 30 must be the time. If they had said, if they talked about a speed, I would look for meters per second next to a number. That's the speed. So let me scroll. It's going to be, over 30 and over 30. And Laney, let me scroll back to the bug way back in example 1. Yep. What distance did the bug walk, Laney? So you can put 14 on the top of the first fraction, yes? What was its displacement? You can put a negative 6 at the top of, okay, let's go. And then let's go to our calculators. So there was a 14 here and a negative 6 here. Get your calculators out, all of you. If you're not typing on your calculator, please be aware that I make a mental note. It means I'm coming at you in the next question or two. 14 divided by 30, that's going to be the same as 7 divided by 15. It's going to be a repeating decimal, but not, Laney, what'd you get? Give me 1 second here. So it's 4 and then the 6 let's go to 3 sig figs. So we're going to go 0.46. Does that third 6 become a 6 or stay a 7? Sorry, stay a 6 or become a, yeah, 467. I would be fussy. If you said 0.466, I would take a half mark off. We're going to round off, not chop off. Units, you can see it's actually hidden in the question. Distance, meters per second. Meters per second. What's the bug's average velocity when you type that in? I can do this one in my head because it's going to be 1 divided by, is it negative 0.2? Yeah? meters per second. Now, what's that negative mean? It means, Georgia, on average, the bug was traveling backwards. Not always, but on average, it was traveling backwards. Okay. Or to the left. So, if average velocity is distance over time, what would be an equation for displacement and for time? I'm going to teach you something called formula manipulation. I'm going to teach all of you to derive equations in your head without memorizing them. If I don't, I gave you all a formula sheet. I would have to give you a formula booklet otherwise. It's going to seem a little weird for some of you at first because I'm going to be pushing you to do math with letters, but please buy into it. If you don't quit on me, I've been able to teach every one of my students this skill with a 100% success rate, and all of them will tell you it drops your memorization down by about 90%. So draw a little line down the middle of the page. We're going to write down the equation V equals d over t, and it's average, so I'll put an AV right there. It wants an equation for displacement. What it's saying is it wants to get the d by itself. Okay. Hudson, what side is the d on, the left side or the right side? What I usually do until I get good is I put a little dot above what I'm trying to get by itself. What else is on this? So what that means, it's on the right side. The whole left side is just going to drop down like a domino. So you can drop down the V-av like that. It's not going anywhere. What else is on the same side as the displacement? What letter? What's the t doing to the displacement? Adding, subtracting, multiplying, or dividing? Where is that t right now in this fraction? On the, it's dividing. So dividing by t on the right-hand side, what's that the same as on the left-hand side? Dividing by t on the right-hand side is the same as doing what with the t on the left-hand side? Malcolm? Yeah, this is your grade 8 equation solving rules and grade 9 equation solving rules, but we're going to be doing them with a vengeance in our head and way further than you go with that. And if you buy into it, again, it's going to seem weird at first, but I've done you a big solid. It'll also tumble into your math classes and into your chemistry classes. So you can multiply the t. Look up, don't write this down. 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 Technically, that equals the displacement, but instead of putting the d there, because we're used to seeing the d by itself over here, let's do that. Write that down. So I imagined the d by itself, and then I said, but I want d equals, not equals d. That's because that's how you're used to seeing it in math. That's another equation. Displacement equals average velocity times time. I don't need to memorize it. I can derive it if I need to. Then it wants an equation for time. I'm going to start with this one. Displacement equals average velocity times time. Jet, I want to get the time, the t by itself. I'll put a little dot above it. That's what I'm staring at. What side is the t on, Jet? Left side or right side? Left side's going to drop down like a domino. I always do that first. Eventually, you'll be doing all of this in your head. What's the v doing to the t? Adding, subtracting, multiplying, or dividing? So if it's multiplying on the right, how could I move it over? So, and then Jet, look up, don't write this down. That equals t, but if you don't mind, I'm going to put the t equals right there because that's where we're used to seeing the thing by itself. Just to give you kind of a preview of coming attractions, you might say, oh, well, there's no way I'll get there. We'll reach the point where we'll see d equals VIT plus a half AT squared, and you'll say, oh, you want to get the A by itself? Not a problem. That's going to be D minus VIT all over 0.5 T squared. That equals A. And if I can get you there, I've dropped your memorization down by 90%. And I will get all of you there at different rates, but we'll get there. We'll get very good at this. Example 7, a motorist travels 350 kilometers during a 6-hour period. What was his average speed in kilometers per hour and meters per second? This is technically, I guess, our first physics word problem. Okay. They're not as scary as the math ones. This is how I always tackle them. Annie, What's this question asking me to find? Unlike the math ones where you're like, I don't know what the stupid X. Here, it's almost always pretty obvious. They'll say, find the, or they'll say, what is the, like. So they want us to find the average speed. So first of all, there's a part A. I'm going to write part A. And then as soon as I figure out what they're asking me to find, which is average speed, I write down its symbol equals question mark. That's my way of saying that's what they're asking me to find. Also, if you've noticed, one of my habits is I like to write something down that's no longer blank. I feel better, just like I did with unit conversion. Now I'm going to go back through the question, and I'm looking for numbers and physics words. You haven't learned any physics words yet, but I'm just building it up. What's the first number that you see? What are the units next to it? Is that a measure of time? No. What's measured in kilometers? You looking for, yes? I'm going to say D equals 350 kilometers. I see a 6. What are the units next to the 6? So what must that be a measure of? How do you know? I don't see the word time anywhere. This is why I said it's worth memorizing what units go with what. It dramatically cuts down on your thinking. So time equals 6 hours. Now, normally I would prefer to convert these into meters and into seconds, but what does it want the units in part A? What are the units right here? What are the units right here? Woohoo! This will work. Um, I want an equation that has a V, a D, and a T in it. Right now, you only know one equation. But as the year progresses, that will be the next question you'll ask, and you'll go scurrying off to your formula sheet, or you might have memorized some of them out of laziness. But I think the equation that we're going to use right now is this one. Average speed is distance over time. What's the distance as a number exactly, Annie? What's the time? What's our speed in kilometers per hour? I think you get 58.3 repeating, right? Because you've typed it into your calculator and you're following along instead of just sitting there aimlessly hoping desperately that nothing will happen. Come on, Splash Zone boy. Thank you. You should all have a 58 point and then 33333 or 3 repeating, however your calculator displays it. Yeah. So I agree to 3 sig figs. It's going to be 58.3 any units, kilometers per hour. Okay. Then there's a part B. So B. B. Christina, what does part B want me to do? What does it want the units in? What's M and a B for? Meters. Meters per second. And that's our preferred unit. Now, I will bring out kilometers per hour because I want to give you all applications, cars, for example. But the SI, the preferred units for speed, are meters per second. So we'll get good at converting between the two. This is going to be our first conversion. I'm going to write down what they gave me, which was 58.3 kilometers per hour. Christina, I need to change kilometers to meters. I need to change hours to seconds. Which one do you want to do first? I don't care, pick. So we're going to have kilometers on the bottom, meters on the top. Kilo, 10 to the what? Where does the 10 to the 3 go? Where the kilo isn't, which in this case is on the top. Christina, do you happen to remember how many seconds there are in an hour? How many seconds there are in an hour? Not 60 seconds in an hour. That'd be a fast hour. Anybody remember how many seconds there are in an hour? Yeah? Let's go there in one step. 1 hour is 3,600. So it looks like now, instead of going 58.3, all of you right now have this on your calculator. Use your answer button. So my answer button is right here. You want to, by the end of this week, know where your answer button is because there will be times when you have to use it. You need to find how to activate it. Times 10 to the third divided by 3,600. In kilometers per hour, this is 16.2. Sorry, meters per second. This is 16.2 meters per second. I like example 8. I like example 8. I like example 8. Example 8 is a nice question. The speed of sound is 343 meters per second. It varies in real life. It depends on temperature and altitude and even how much rain or how much humidity there is. But on average, it's 343 meters per second. Sheldon is shouting at the base of a steep mountain. If it takes 3.2 seconds for Sheldon to hear his echo, how far away is the base of the mountain? Ooh. Did I say I like this question? I like this question. I like this question. I should have said, I did say that? Okay. Nate, what's this question asking me to find? Good. I first, if you had said how far away, I would have said yes. Now translate that into a physics term, and you said how far away. That's not speed. That's not time. Distance. You know what? Let's write down d equals question mark. What's that 343? That's the units. What is it as a physics concept? Yeah, and even if they hadn't said that word there, the meters per second would have told me it's a speed. This is why I'm telling you, as this unit progresses, it's worth making a little effort to memorize what units go with what. If you make a little effort, it'll happen. So I'm going to say V equals 343. What's that 3.2? How do you know? Yeah, okay, seconds. What's it a measure of, though? Time. Now, the other thing that I was doing is I was checking to make sure all of our units matched. In other words, up here, they wanted an answer in kilometers per hour. We had kilometers an hour. We're good. Here, we have meters per second and second. We're good. If this had been hours or if this had been kilometers, before I could do anything, I'd have to do a conversion. We'll do one like that in a bit. I'm looking for an equation that has a d, a v, and a t in it. There is one. Well, technically, it's this one, v average equals d over t, except let's get the t by itself. Sorry, let's get the d by itself. I said that wrong. Let's get the d by itself. How would I move the t over? So I think you're telling me that v times t, and if you don't mind, I'm going to put the d right there. What's the speed? As a number, yeah, read it to me. What's the time? Type this into your calculator. What do you get? $1,097.6. Is that correct? Yeah. Why is that wrong? Because it is wrong for a candy. Who can tell me why that has to be wrong? Okay, specifically for echoes, that 3.2 seconds was there and what? So we're going to write 1097.6, and then we're going to say divide by 2, and you can make a little note there and back. So go answer button divided by 2. Oh, answer button divided by 2. To 3 sig figs, I'll call it 549. That's meters. How do I know it's meters? Because distance is measured in meters, and meters were the units that we stuck in originally. By the way, anybody ever been at a place where there's a really, really nice echo? You can use this to figure out how far away whatever you're echoing off of is. This is how sonar works. So if boats or submarines are using sonar, they're doing the same thing. They're measuring the time it takes for them to hear the echo. They're dividing it, or they're multiplying it by the speed of sound and dividing by 2. That's how far away the object is. Bats do the same thing. Other animals also use sonar. I like this question. I like this question both because to me it's a nerdy application, but kind of cool. I like echoes; they're cool, and also this little aha there and back. So Malcolm, I promised you a candy. I always say when I give out a candy, always forget to give out a candy. If I forget, hit me up the next day. Remind me. Good. You all turned the page. We're nearly done. We're going to be going from meters per second to kilometers per hour to meters per second to kilometers per hour fairly often. Meters per second is the units that we prefer. Kilometers per hour is the SI units. And so we're going to develop a shortcut. I want you to notice when we went from when Annie and I went from kilometers per hour to meters per second, we times by 1,000 and we divided by 3,600. Really what we did is we divided by 3.6 because the thousands would cancel out. So to go from kilometers per hour to meters per second, if you draw a little arrow, it's divide by 3.6. Anybody want to guess if you're going to go from meters per second to kilometers per hour, what you do with the 3.6 instead? All of you want to write that on the bottom of your green sheet on the front page. I think that's kind of clear enough, or some version of that, so that you have the shortcut on your formula sheet. You'll probably end up memorizing it because you're going to get lazy, but it's going to be there. Put it on the front page, on the bottom. You can put it on the back page if you want to be you, but I said front page because it's going to be in the unit. Anyways, whatever. Front page. So kilometers per hour to meters per second, it's divide by 3.6. Meters per second to kilometers per hour, it's times by 3.6. Is that okay, Stephen? I know it's a long lesson, but you're going to make it. We're nearly there. I think one more and a couple of questions. Jeremy is driving at 18 meters per second. If he drives for 2.5 hours, how far will he travel in kilometers and in meters? Why is this question yucky? Can we see it? Yeah, Charlie. Do we? It's not quite why it's yucky. You're on the right track. The speed is in meters per second. What's the time in? Our units are all mismatched. If everything was seconds, happy joy. Or if everything was hours, happy. I could do meters per hour. It'd be a weird unit, but at least mathematically, I'd be sound. I'm going to have to do a conversion. So, Charlie, what does it want the answer in A to be in? I think I'm going to convert this to kilometers per hour. Okay? So, first of all, what are they asking me to find in this question? When it says how far, D equals question mark. What's that 18? What are the units next to that 18? So what's it a measure of? Speed. So I'm going to write V equals 18. I'm going to write meters per second, and I'm going to put an equal sign next to it because I need to convert it. What do I need to convert it into? Kilometers per hour. It's something to do with the 3.6, but I can't remember if it's times or divide. Oh, wait a minute. You put this on your formula sheet, so you wouldn't have to remember. Is it times or divide by 3.6? Times? So 64.8 kilometers per hour. And then what's that 2.5? What's that 2.5, Charlie? What are the units next to that 2.5? So, what's it measuring? Starts with letter T. Here you go. I got hours, I got kilometers per hour. There's no mismatched units there. I'm good to go. I'm looking for an equation that's got a D, a V, and a T in it. Well, right now you kind of only have one. You're going to say, hey, D equals VT. Eventually we'll have more, but I'm building the pattern of thought. So it's going to be 64.8 times 2.5. What will the distance be? This is what you do when you're driving on a road trip and you're just, how far have we gone? Well, we've driven this fast for this long. Oh, 162 even? Yes. Units? Good. And then part B says, oh, Luke, what does it want the units in? I'm going to ask, maybe some of you can you convert kilometers to meters in your head? How many meters in 1 kilometer? So how many meters in 162 kilometers? That's one that's worth knowing because you're all getting your driver's license. You should know how to go from kilometers to meters. 1 meter is 1,000. Sorry, 1 kilometer is 1,000 meters. 2 kilometers, 2,000 kilometers times 1,000. Example 10. True or false? Don't blurt out an answer. True or false? An object can have a positive distance while having a displacement equaling 0. What we're going to do is we're going to vote. How high you hold your hand up is how sure you are of your answer. I'm positive! I'm pretty sure I'm only voting because Mr. Dueck can make fun of me if I don't vote, and Mr. Dueck will make fun of you if you don't vote. Count on that. So here's the question, true or false? An object can have a positive distance while having a displacement equaling 0. Who says, I think that's true, Mr. Dueck? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Who says that's false? Go ahead, Luke. You might be right. Convince me. So you can either attack someone else's answer as I know they must be wrong, or you can defend your own answer as I know I must be right. Convince me. I'll let the awkward silence go for a while. Convince me. Laney, if I tell you the answer is true, can you give me an example of how it could be true? More specific, can you stick some numbers in there? Hey, you know what? Even more basic than that. 1 step forward, 1 step backward. What's your displacement as a number exactly? Everybody. What's your distance? 2. Positive distance, 0 display. Good. Luke will remember. I just saw his brain click. You'll remember that. That's why I do a lot of these thought puzzles. So you have the, oh yeah. Okay, next one. True or false? Again, we're going to vote. An object can have a positive distance while having a negative displacement. Who says, yeah, I think that's true, Mr. Dueck? True. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, we got a wave coming here. I love Owen. Owen's trying to blend it. He did a vote like this. So maybe Mr. Dueck will just put me on the right one no matter what. I'll just twitch my hand. You know, it's like the kids. You're on the true false test, Owen. You're the one that does this, right? What do you think it is, Mr. Dueck? Give me the right answer. Right. I know you. Okay. So convince me. Give me an example. How can that be true? If you moved from -5 to 0, I would argue you had a positive displacement because you've moved to the right. Reverse that. Okay. Let's say two steps backwards. In fact, even 1 step backward, distance has no direction, much like your future. It has no direction, and so you would say that's a distance of 2, a displacement of -2. Next page. An object can have 0 distance while having a positive displacement. Ooh. 0 distance while having a positive displacement. Who says true? Who says false? You're correct. Now, this one is a much tougher one to prove. All I can say is I can't think of an example that would make it true. Because if you have 0 distance, you haven't taken any steps. And if you haven't taken any steps, have you changed your position? No. One of my favorite comics is Foxtrot. The author, Bill Ammond, actually has a physics degree. He was doodling in university while getting his physics degree, and his friends said, you know, these are funny, you should publish them. So he also publishes, it's Foxtrot is about a family, and Jason is the young nerd boy. For some reason, I empathize with Jason. Go figure. They're playing football. Jason is playing football with his brother Peter. Jason says, okay, here's the play. Go 40 yards downfield, then turn left, go 20 yards, then turn right, and go 25 yards, then turn right, and go 30 yards. Then turn right and go 30 yards, then turn left to go 10 yards, then turn left to go 15 yards, then turn left to go 20 yards, then turn left to go 50 yards, and I'll hit you with the ball. Peter thinks for a while, and then he says, won't I be right back where I started? Jason says, well, I can't throw very far. Okay, so what distance will Peter run in order to complete this play? Well, it's going to be 40 yards downfield, then 20 yards, then 25, then 30, then 30, then 10, then 15, then 20, then 50. What do you get? I can do this in my head. I bet you I can beat some of you on your calculator. It's going to be 60, it's going to be 85, it's going to be 115. Yes, it's going to be 145, 155, 160, 170. It's going to be 170 plus 7. Double check me. Is it 240? I might be wrong. See what you get. Steven's on his calculator instead of just waiting, hoping somebody else will do the math for him. Figure it out. If you're not on your calculator, I'm coming at you. Ben, what'd you get? It is 240? I did it right in my head? You did too? Woohoo! We'll have a math challenge. We'll have a face-off eventually. Okay, what's Peter's displacement exactly as a number if he ends up back where he started? Okay, it's raining outside. I have, on a sunny day, taken my students out onto the football field, and we've run this. The physics is accurate. You do end up back where you started from when you run the play. And so I do admire the fact that he made sure the physics was correct. Your homework is every question. You can do it this weekend if you know you're going to be busy, but I don't see until Tuesday. You can also save this for Monday night if you want to. So number 1 is good. 2 is good. 3 is good. 4 is good. 5 is good. 6 is good. 7 is good. 8 is good. You know what? You can cross out 9. I'll let you skip 9 because 8 and 9 are kind of the same, similar questions anyways. 10 is good because we get to talk about the moon. And I did attach the answers on the very, very last page. Where's question 5? It means I had a where's question 5? Right there. Sometimes you'll see a number missing. That means there used to be a question there, and then I didn't like it and deleted it, but I was too lazy to redo all the numbering. You caught my laziness. Thank you for your patience.